Hello everyone, welcome to Math Cyberspace. This is Dibyendu Ganai and today this is our practice set 3. In practice set 3, there are some questions of linear differential equation. But before that, we will solve the questions of practice set 2. In practice set 2, the first question was question number 6. Question number 1 to 5 was in practice set 1 and in practice set 2, this is from 6 to 10. Question number 6 is let y be a solution of y dash equals to e to the power minus y square minus 1 on closed interval 0 1 which satisfies the boundary condition y0 equals to 0. Sorry, this is initial condition. Then option 1 yx greater than 0 for x greater than 0. Option 2 yx less than 0 for x greater than 0. Option 3 y changes sign in closed interval 0 1 and option 4 is y equals to 0 for x greater than 0. This question has been asked in GATE 2008. Here, if the initial value problem is of the form dy dx equals to f of xy and the initial condition is yx0 equals to y0. If you see that the function f is continuous and it satisfies the Lipschitz condition. Okay, f is continuous and it satisfies the Lipschitz condition. In that case, the initial value problem will have a unique solution. Now, in the given problem, what is our f? F is equals to e to the power minus y square minus 1. And this is continuous and Lipschitz. So, this problem will have a unique solution. So, in option 4, y equals to 0, this is our unique solution. So, option 4 will be correct. Now, question number 7. Question number 7 was the equation of the curve satisfying sin y dy dx equals to cos y into 1 minus x cos y. And passing through the origin is, we have to find out the equation of the curve. Okay. This question has been asked in IIT JAM 2013. The question is sin y dy dx equals to cos y into 1 minus x cos y. We divide both sides by cos y. Then we get tan y dy dx equals to 1 minus x cos y. Then simplifying this equation, we get tan y sec y dy dx minus sec y equals to minus x. Now here, this is tan y sec y dy dx. This is minus sec y. Okay. Now if we put z equals to sec y, then we get dz dx equals to sec y tan y dy dx. Now we replace the value tan y sec y dy dx with dz dx. Okay. So the equation number 1 becomes dz dx minus z equals to minus x, and this is of the form dy dx plus py equals to q, where p and q are functions of x or constant. So in that case, what will be our integrating factor? Integrating factor will be e to the power integration p dx, and here p is equals to minus 1. In that case, p is equals to minus 1. So our integrating factor is e to the power integration minus dx, that is e to the power minus x. So e to the power minus x, this is our integrating factor. Now what will be our solution? Solution is z into e to the power minus x integration minus x e to the power minus x dx plus c. And integrating this, we are getting z equals to x plus 1 plus c e to the power x, where c is an arbitrary constant, and z equals to sec y, we put z equals to sec y, so sec y equals to x plus 1 plus c e to the power x. Now at the origin x equals to 0 and y equals to 0 and sec 0 equals to 1, so 1 equals to x equals to 0 plus 1 plus c, so c is equals to 0. So our required equation is sec y equals to x plus 1. Sec y equals to x plus 1. Okay. Now, question number 8. Here given, consider the differential equation mod y dash plus mod y equals to 0. Then which of the following statements is true? General solution exists. General solution exists but contains no arbitrary constants. Option 3, it has particular solution which is bounded, and option 4 is none of the above. Since this differential equation, this initial value problem has no initial condition, in that case only x equals to 0 will be the only solution if solution exists. So option 3 will be correct. Now question number 9. Question number 9 is the initial value problem x square minus x dy dx equals to 2x minus 1y. Okay, and the initial condition is y(x0) equals to y0. It will have a unique solution if x0 y0 equals. We have to find out the value or find out the point x0 y0 for which we will get a unique solution. Okay, and 4 options are given. Let's see the solution. This is our given differential equation. We rewrite this differential equation in this form. Okay, now x square minus x equals to x into x minus 1. We simplify this. Okay, we simplify in this form. Then we get dy by y equals to 1 by x plus 1 by x minus 1 dx. Now integrating, we get log y equals to log x plus log of x minus 1 plus log c. And removing log, we get y equals to cx into x minus 1. C is our integrating constant. Okay. Now in option 1, the point is 2, 1. Okay. If we put x equals to 1 and y equals to 2, then we get c equals to half. And when c is equals to half, yx equals to x into x minus 1 by 2. Yx equals to x into x minus 1 by 2. And this is our unique solution. So option 1 is correct. Now in option 2, the point is 1, 1. If we put x equals to 1, then we are getting the right side is 0, but the left side is 1. So 1 is equals to 0. This is not possible. So there is no solution. So option 2 is wrong. And in option 3, the point is origin, that is 0, 0. Okay. If we put x equals to 0, and we are getting right side 0 and left side is also 0. So in that case, we will get infinite solution because C is arbitrary. Okay, not unique solution. So option 3 is also incorrect. And in option 4, the point is 0, 1. If we put x equals to 0 and y equals to 1, then we are getting again 1 equals to 0, which is not possible. So in this case, no solution. So option 4 is incorrect. So only option 1 is correct. Okay. Now question number 10. Question number 10 is for non-homogeneous equation y dash plus px y equals to rx. If y1, y2 are its solutions, then the solution of homogeneous equation y dash plus pxy equals to 0 is. 4 options are given. Here, since y1, y2 are the solutions of this non-homogeneous equation, then we can say that y1 and y2 satisfy this differential equation. So we can write y1 dash minus pxy1 equals to rx and y2 dash minus pxy2 equals to rx. This is equation number 1 and this is equation number 2. And subtracting 2 from 1, we are getting y1 dash minus y2 dash minus px y1 minus y2 equals to 0. From this equation, comparing with the given differential equation, we can say that y1 minus y2 satisfy the equation y dash plus pxy equals to 0, and so y1 minus y2 is the solution. So option 1 is correct. Okay, this was our questions of practice set 2. Now we will see the questions of practice set 3. Question number 11. The general solution of the differential equation with constant coefficient d2y dx2 plus b dy dx plus cy equals to 0 approaches 0 as x tends to infinity if there are four options given. Okay, we have to check what is the sign of b and c. What is b and c? B is positive or negative, or c is positive or negative. Okay, this question has been asked in IIT JAM 2016. Now question number 12. Here y1x equals to x cube and y2x equals to x square mod x for x belongs to R. Consider the following statements. Two statements are given. y1, y2x are linearly independent solutions. Okay, y1, y2 are linearly independent solutions of the given equation on set of real numbers. And statement Q is the Wronskian y1x dy2 dx minus y2x dy1 dx equals to 0 for all x belongs to R. We have to check which statement is correct. Okay. Question number 13. If xt and yt are solutions of the system dx dt equals to y and dy dt equals to minus x with initial condition x0 equals to 1 and y0 equals to 1, then we have to find the value of x pi by 2 plus y pi by 2. This question has been asked in GATE 2017. Now question number 14. Here given, let W be the Wronskian of two linearly independent solutions of the ODE 2y double dash plus y dash plus t square y equals to 0, and where t belongs to R. Then for all t, there exists a constant c belongs to R which such that Wt, that is Wronskian, is, we have to calculate the Wronskian. This question has been asked in CSIR NET 2013 December. Now the last question of practice set 3, question number 15. If the orthogonal trajectories of the family of ellipse x square plus 2y square equals to c1 and c1 greater than 0 are given by y equals to c2 x to the power alpha, where c2 belongs to R, then what will be the value of alpha? Okay, this question has been asked in IIT JAM 2017. Okay, this was our practice set 3. I will solve the problem and send the solution in our Telegram channel. You may join our Telegram channel for our solutions. Also, I will upload the solutions on the next day to our YouTube channel. Okay, thank you for today. If you like this content, then please subscribe our channel and share with your friends. Thank you.